There's something truly amazing I would like to show you today. I built this circuit which detects mobile phone energies more accurately than before, and it uses this large yellow loop antenna between an op-amp and a transistor. Now while I was doing it, I noticed if I put my hands somewhere near that yellow antenna, it would turn on the LED light. Or I could put it in the middle of the loop, around the loop, or through the middle of the loop. So why is my hand turning on the LED? There's something about wireless energies it's receiving or emitting them which we don't know about yet in terms of normal science. Now I want to show you how a Wi-Fi extender antenna would also do the same thing. You bring a Wi-Fi extender antenna close to the device and you put its antenna inside there. It turns on the light again. Move the extender back, the light goes off. Bring the extender forward, the light comes on. Push the extender back, the light goes off. Your hand does the same thing as the antenna. Hand in, hand out. Hand around, hand out. Hand in, hand out. Are you convinced now? Is this prana? Is this chi? What are we measuring here? What are we studying? I'm not exactly sure, but it's certainly scientific and it deserves further attention, as we will do in this video. Today we're going to do a brief follow-up on a circuit which I mentioned in a previous video, which can seemingly detect wireless energies from the human hand. And here's the circuit here, which I'll show on the next slide. It's a mobile phone detector circuit, which I've made more sensitive by adding a bigger loop antenna in that part. Let's look at the data now from various objects and see what we can conclude. When we place wires at 300 volts DC near this new detector, here are the wires plus and minus, anywhere we put them, 300 volts DC, the detector light over here won't come on. But if we put our hand inside, now the light comes on. Next, if I put wires at 40 volts AC wall power near this device, the light again doesn't come on. The detector light remains solid. But look what happens if I put my hand through the detector. As another example, if I put a small electromagnet in the center of the detection loop with about 400 turns, and I give it 40 volts AC wall power at 50 Hertz, let's flick on the switch. I get a quick flick of the light when I flip the power on, but after that, nothing. When I flip the power off, another little click switch. So it'll detect changes in voltage to the electromagnet, but not the magnetic field itself. Another interesting phenomenon is if I take a huge piece of copper tubing and put that in the loop, that turns the light on. It acts like a huge antenna is just soaking up all the electromagnetic energy in the room around me. And then if I take that out again, the light goes off. The bar of copper has to be really large. Smaller tubes of copper like this one won't do anything. Now if we take a Wi-Fi extender and bring its antenna close and put it near this device, at some distance, the strobe light will start blinking. If we put it even closer, start blinking more. If we put the antenna inside the device, it'll turn on completely, like for our hands or our copper wire. Let's take it out again. Pull it out a little further, it's blinking. Pull it away further, the light goes off. We learned a lot from that experiment, didn't we? Let's put our hands in again. So our hands are just like a Wi-Fi extender antenna. There's one final demonstration which I've done before. If we send a GIF video from our phone, that will trigger the light as well due to the 2 gigahertz wireless energy while the GIF movie is sending and receiving. That was sending, and now it's receiving. And then it shuts off again. Someone also said it might have something to do with heat. Heat from my hands could be triggering it. So I lit a match, put the match inside the detector, and as you can see, nothing happens. In order to characterize what kind of electrical signal is being induced by my hands in this detector, I'm going to use my laboratory Tesla-coil as a control. The light from the Tesla-coil will light up over here. Right now it's off. And I've put 2 little wires around the LED above and below it, and we're going to look at DC voltage, AC voltage, frequency, and current. So here's the DC voltage with the Tesla-coil off. Here's the AC voltage with the Tesla-coil off, and there's no light either. Here's the frequency, as you might expect with the Tesla-coil off. The light's off. And here are the milliamps going through it. Now with the Tesla-coil turned on, you can see the light at about 10 watts. The LED light is turned on. We register about 1.34 volts DC, about 0.50 volts AC, which is much higher as you might expect. A frequency of about 260 kilohertz, which is about half what's over there, because once it goes to the transistor it's pulse DC rather than AC. And a current in milliamps of about 39 milliamps. And you see the LED turns off when we measure milliamps because the current's diverted. We go back to voltage, the LED turns on. In summary, we used our laboratory Tesla-coil as a control to measure voltage DC, voltage AC, frequency, and current across the yellow LED light. The Tesla-coil at its source runs at 470 kilohertz, and we measured with the LED off versus on. You can see there's a bigger increase in AC volts, which you might expect getting energy from a Tesla-coil, and also a big increase in frequency to 260 kilohertz. Now that's less than the 470 at the source, because this is pulse DC radiation coming through a transistor, which can only put out DC, and that was wireless AC irradiation. So our control experiment worked fine. Let's see what we get now using human hands. Next, we're going to do the same experiment with human hands. Now with the LED off, we see a DC voltage of 1.22 volts, and AC voltage of about 0.06 volts, a frequency of 0 as you might expect, and the milliamps going through is about 42 milliamps. Finally, is the critical experiment. When we put our hands to the loop and turn on the light, we see a DC voltage of 1.19 volts, an AC voltage of huge 0.9 volts. Taking the hand out, put the hand back in. Take the hand out, put the hand back in. Thus we're getting a huge AC signal from the hands, which needs to be further characterized. Interestingly, the multimeter I'm using here can't detect the frequency of that radiation. That might be because it's not one wavelength but a spectrum. I think we're going to need a spectrum analyzer to figure out what's happening here. Lastly, the current going through the loop is still about 43 milliamps. And you see we've lost the LED light because the current's being diverted. When I turn back to voltage, the LED light comes back on. In summary, when we use a multimeter, to measure electrical properties across the LED of our detector and place human hands inside, we can see a huge increase in the AC voltage signal from 0.06 to 0.91 volts, which is really pulse DC because it's coming through a transistor. But we can't read a frequency like we could for the Tesla-coil, and that suggests that it might be multi-wavelength and we need a spectrum analyzer. A multimeter itself might not give any well-defined frequency as a single value. This is still a very interesting result, which needs to be characterized further, and there's no telling where it would go. Before we conclude, let's explore the electrical characteristics of our detector a little further. If we go to its standard antenna, which lies upstream of the op-amp, we put a 1.5 volt DC battery there, one end into the antenna, the other end a touch connection to ground on the power supply, and we're going to look to see what happens. It starts at a DC voltage of 1.4 going through the LED, and then when we do the touch connection, it goes way up to 2.056 and the LED comes on. We take off the touch connection, the LED stays on for a second, and it drops back to 1.44. So clearly we're getting a change in DC voltage, not AC. Let's look at the AC at the same time. The AC starts at 0.03. Now we'll make a touch connection to ground. The LED comes on. We have zero AC coming in. It's all pure DC. We release it. The LED stays on for a second. Then goes back to 0.03. Therefore, our standard antenna here with a DC battery connected to ground has a pure DC voltage signal and nothing to do with AC like we're seeing in the loop antenna. If we now remove the battery and just touch this antenna with human hands, it starts off at a DC voltage of 1.49. We touch it, the DC voltage actually goes down a little bit when the LED comes on release. Let's look at the AC voltage. We'll touch it with human hands. The light comes on. The AC voltage goes way up to about 0.4, goes back down to almost nothing with no touch. Touch it again. Light comes on, goes up to 0.6, release it, goes back down to nothing. Let us summarize now what we just measured. For the standard antenna, which lies upstream of the op-amp, we measure voltages DC or AC downstream across the LED, which lies past the transistor. So if we put a DC battery input of 1.5 volts into the standard antenna, we see the DC output way downstream go from 1.44 to 2.05 volts DC, which is a pure DC signal, and there's no effect on AC. On the other hand, if we touch it with human hands, that antenna upstream, we see a slight decrease in the DC coming out downstream and a big increase in the AC signal from 0.01 to around 0.4 to 0.6 volts AC. So clearly the human hands are providing an AC signal. And in the human hands in this case, if we don't touch, we have a wireless contact nearby, there's no effect. Unlike for the loop antenna where wireless connections everything. In summary, this standard antenna, which lies upstream of the op-amp, in a place that everybody uses, will take DC voltage from a DC battery that's connected to ground to produce a DC output across the LED way downstream. It will also take AC voltage from your hands on contact, produce AC voltage across the LED way downstream. However, it's not sensitive to wireless contact with your hands, like for this yellow loop antenna. Wireless contact will turn that one on, but a wireless contact over here will not turn the LED on. It'll only do it through the loop antenna. In summary, by studying today diverse objects such as DC power supplies, AC power supplies, AC electromagnets, Wi-Fi extenders, big pieces of copper which act as antennas in mobile phones, we have learned quite a bit more about what will trigger this detector that also registers wireless energies apparently from the human hand. We have to do more research to find out exactly what they are, and I'll just note that the Chinese people call this chi, the Indian people call it prana. That's not a very scientific explanation, but with further science I'm sure we can gain further insight. Thank you very much and best wishes to all.